All right. Unit 6, Section 1. Let's talk about interior and exterior angles of polygons. A polygon is a closed figure formed by 3 or more line segments called sides. Has to be 3 or more. Only 2 line segments just forms an angle. You'd have to have a third to close the body and to turn it into a polygon. All right, so we have a triangle. That'd be your first kind because you'd have to have at least 3. The sum of the measures of the interior angles of any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look at the pattern to find the sum and the degrees of any polygon. So if we look at a triangle, it's got 3 sides. The number of triangles in a triangle is 1 triangle. And the sum of all the interior angles of one triangle is 180 degrees. A quadrilateral or a quadrangle or a rectangle doesn't have to be a rectangle, it could be a rhombus. It just has to be a 4-sided figure. You can draw one diagonal without crossing any other diagonals, creating 2 triangles. So if we have 4 sides, we'll create 2 triangles. 2 triangles totals 360 degrees. A pentagon, 5-sided figure, sorry about the zoom in there, has 3 triangles, which makes it 540 degrees. 6-sided hexagon gives you 4, which is 720 degrees. A heptagon has got 7 sides. It's got 5 triangles. It's 900 degrees. An octagon's got 8 sides, 6 triangles, 1080 degrees. 9 sides, 7 triangles, 1260 degrees. 10 triangles, 8 sides, 1440 degrees. Now those of you that play the skater or the snowboarder or any of those other kind of games where you're spinning circles and you have to create 900s and 1080s and 1440s and all of those kinds of things, that's where all that comes from. It's rotations around a circle. It's 360 degrees all the way. Okay. Now what we see is as the sides go up, the number of triangles go up. As the number of triangles go up, it goes up by 180 each time. So if n represents the number of sides of a polygon, then the sum of the interior angle, big S, can be found using the formula sum equals n minus 2, where n is the number of sides, times 180. So you take the number of sides, take 2 off, multiply it by 180, and you know then the sum of all of the angles of a polygon. You could also write this as 180 times n minus 2. And all I did was rearrange the 180 and the parenthesis, because you can multiply in any direction. So it doesn't matter which way you write it. If you do the multiply after the parenthesis, it's good to put the dot there. But if you put it in front, you don't need the dot. So let's see how this works. Let's find the sum of the measures of the interior angles of each polygon. Number 1, we have a 15-gon. Yeah, and once you get past decagon, well, there's a hendeca, which is 11. And then there's dodeca, which is 12. And there are more. You're welcome to Google them, but those are the ones you'll get the most. Dodecagon seems to come up in trivia game questions, so it's good to know that one. But once you get up there, it's just a 13-gon, a 14-gon, a 15-gon, a 16-gon. So number 1 here is a 15-gon. So the sum is equal to 15 minus 2 times 180, which is 15, let me go, parenthesis, 15 minus 2, parenthesis, times 180, enter, 2340. There's 2,340 total degrees inside that triangle. Let's look at number 22, or number 2. It's a 21 gon, so the sum total on the inside is 180 times 21 minus 2. I'm using the secondary formula there, so this time if we do 180 times 21 minus 2, we get 3420. It's a 4, I promise. Degrees. It's always degrees on the inside. A 48 gon, the sum total equals 48 minus 2 times 180. I switched back to the other form again, so let's see, 48 minus 2 times 180. 8,280 degrees. And then our last one, 36 gon, the sum total equals 180 times 36 minus 2. So 180 times 36 minus 2 is 6120. And it should be less than a 48 gon, and it should be more than a 21 gon, and it's between them, so that makes sense, which is good. All right, now let's talk about regular, the word regular. A regular polygon, okay, that's very important. I'm going to highlight that word regular. I'm going to do it twice, get it dark. Here we go. One more time. Regular polygon. Regular polygon. The measure of a single interior angle in a regular polygon can be found by dividing the sum of the interior angle measures S by the number of sides. If it is regular, actually, let me do it this way. I got room for it. Regular polygon is a polygon, since there's a nice room line right here, in which all, I'm going to go capital, side measures are congruent. Therefore, or so, all angle measures are congruent. I'm going to use the symbol because I ran out of room. All the sides are congruent. All of the angles are congruent. So this is equiangular and equilateral. Okay. Find the measure of each interior angle of the following polygons. A regular pentagon. So regular tells us that all the sides and all the angles are the same. So we know the total of a pentagon. We divide that by 5 because there will be 5 angles in it. We will know 1 angle in a regular pentagon. So let's find the sum total. 180 times 5 minus 2. Bring back the calculator. 180. That's supposed to be an 8. 5 minus 2, which is 3. Okay. 540. And we divide it by the number of sides. Okay. So that's going to be, need my calculator back. Come back. Clear. Divided by 5. Look. 108 degrees. Oh, don't need that. Okay. So we could write it as a full-on equation where we could say, I don't know what we want to call it, but it's not necessarily the S. I guess S, they used it up in here. So we could say the big S this time is 180 times n minus 2 over n. That's the equation there. N being the number of sides that you have. So, try number 6. Let's see what you get. Give it a pause. Try number 6. Let's see what you get. Okay. So, 180 times 18 minus 2 over 18. We'll do the whole thing this time. I need alpha y equals n over d. 180 times what is it, 18? What are we doing? 18 gone? 18 minus 2 over 18. Dink! 160. Just like that. I want to see the equation before you do the type in the calculator. Make sure you're typing it right. Exterior angles. Remember, exterior is outside. Exterior angles are supplementary to their adjacent interior angle. Remember, supplementary means they add to 180. Find the measure of each exterior angle on the polygons below. Then give the sum of all exterior angle measures. Okay, so each one of these, as we extend the side, making a linear pair. Okay, we got 180 minus 61. It's 119. We got 180 minus 79. That's 101. We got 180 minus 40. That's 140. So 119 plus 101 plus 140. Enter. It's 360. That's not a 6. 360 degrees. So that was a triangle. Let's look at a quadrilateral, four-sided figure. 180 minus 124. It's 56. 180 minus 76. Don't need the plus sign. There we go. It's 104. 180 minus 89. It's 91. 180 minus 71. It's 109. 56 plus 104 plus, plus 91 plus 109 is 360 degrees. Interesting. Let's go with a pentagon. 180 minus 98 is 82. 180 minus 121 is 59. Don't forget your degrees. 180 minus 87 is 93. 180 minus 130, 50. 180 minus 104, 76. 76 plus 82 plus 59 plus 93 plus 50 equals 360 degrees. Do we see a pattern yet? Why don't you try the last one by yourself? Give it a pause. Let's see what you get. Okay, here we go. 180 minus 129 is 51. 180 minus 124 is 56. 180 minus 112 is 68. 180 minus 123 is 57. 180 minus, that's 480. 180 minus 117, 63. 180 minus 115, 65. So we got 65 plus 51 plus 56 plus 68 plus 57 plus 63 plus 65. No, we already did 65. Enter. 360. Interesting. So what do we see? What do we notice? What do we feel? What can you conclude about the sum of the exterior angles measures of a polygon? Well, the sum of the exterior angles of any polygon is 360 degrees. Boom. So what is the measure of each exterior angle of a regular hexagon? Well, we have some words in there that are important. We've got exterior, we've got regular, and we've got hexa. Exterior means it's on the outside. The total is 360. Regular means that they're all going to be the same, so I can just divide it by however many angles there are. A hexagon, hexa is 6. So I take 360, divide it by 6, drop the 0, 36 divided by 6 is 6. They're all 60 degrees. What is the measure of each exterior angle of a regular 24gon? Well, all of them together is 360. There are 24 of them, so I'm going to divide it into 24 pieces. And so I do 360 divided by 24, and I get 15 degrees. If the exterior angle of a regular polygon measures 12, so if 360 divided by something equals 12 degrees, how many sides does it have? I don't know. That's the x part. Now, the fun thing about proportions, right? Because if I've got 360 over x equals 12, that's technically, and I'm going to show you in a different color because I want you to think about it separately, but that's technically like this. And in proportions, you can switch diagonally one direction. And the reason you can do this is because it would be like if I multiplied this side by x and that side by x, which means that was cross out, and then I divide this side by 12 and I divide this side by 12, and so that these cross out, I'm left with 360 over 12 equals x. You can switch diagonally in a proportion, so a fraction equals a fraction. You can switch the diagonals once. So that means I can change this to 360 divided by 12 equals x. And so x equals, we just got to do 360 divided by 12. 30 degrees. Okay. If the exterior angle of a regular polygon measures 40, so if 360 divided by something equals 40, how many sides does it have? Well, I'm going to do a diagonal switch, and I'm going to say 360 divided by 40 equals x. Drop the zeros. 36 divided by 4. That's a 9, actually. Didn't need that. Whoa. Where's my eraser? I'll make a pinpoint eraser. Here we go. There's a 30-side gon. Right? And now it's a 9-side gon, since every angle is bigger. So 9 sides, just like that. Okay. That's all it takes. Interior and exterior angles. Interior angles, 180 times n minus 2, where n is the number of sides that you have. Exterior angles is always 360. And if it's regular, you can divide it by how many sides, you know how much each one is. But the outside totals will always be 360. Good luck on